Do you want to learn how you can set up a platform that accepts WebSocket connections using just API Gateway, Lambdas and Dynamo DB? In this video, that is exactly what I'm going to show you how to do. Hi guys, my name is Sam with Complete Coding, and in this video we're going to be learning how we can set up a platform that accepts WebSocket connections and handles them through API Gateway, Lambda and storing the session data in Dynamo DB. WebSockets are great as it allows a two-way connection between parties. Unlike APIs, which typically are a single request followed by a single response, both sides of the WebSocket connection can send multiple messages down the WebSocket at any point during the connection. This is great as it allows you to send updates whenever things happen on your system, as well as the user to respond with messages at any point without having to wait to respond to one of the requests. So now we're going to jump into the code and see how we can set up this whole platform. Before we start creating the code that is going to enable us to create a Lambda WebSocket, we're going to do some cleaning up inside this project so that we have a nice clean folder system to start from. The first thing we're going to do is go into endpoints, select all of the endpoints and delete them. We're going to keep the common code as that may be useful in the future. The next thing we're going to do is delete the upload data folder, as well as the handler.js. The last thing we're going to do is delete the webpack config, as we won't be using webpack for the rest of these functions. Now we can go into our serverless YAML file, and we're going to change a couple of things. We're going to update the service name to my serverless project 2. We're still using AWS, but this time we're going to be using the newest version of Node, which is Node 12.x. We're using the same profile and region as before, but we can remove the environment and IAM role statements. In terms of plugins, we can delete all of the plugins and also this package configuration. We can then also delete the custom information, just like that. And we can also remove all of the functions as well as all of the resources. This may look like a very bare serverless YAML configuration file, but that's exactly what we want, as it means it's easier to create new functions. Now that we've got a nice clear folder structure inside our project, we can start building the code for our WebSocket Lambdas. WebSocket Lambdas with API Gateway work by AWS creating a WebSocket connection and then hitting one of your Lambdas every time one of our functions is called. This might be on a connection, on a disconnection, or on a message being sent down the WebSocket. So what we're going to do is we're going to create those Lambdas. These aren't common Lambdas and these aren't endpoints, so we're going to create a new folder and we're going to call this folder WebSockets. Inside here, we're going to create a couple of new files. I'm going to use the terminal, so I'm going to cd into lambdas/websockets, and I'm going to make a connect.js. I'm going to make a default.js, a disconnect.js, and finally a message.js. So now if we look inside our WebSockets folder, we can see that we have each of those. We're going to start with the connect.js, and this is going to be an API which is called every time someone connects to our WebSocket. We're going to start very simply. The first thing we're going to do is have a handler. So exports.handler is an async function that takes an event. Inside here, the first thing we're going to do is console log out the event. We're then going to return a 200 response of connected. So here we're going to return responses dot underscore 200, passing a message of connected. Here, responses isn't defined because that is one of our common functionality. So what we need to do is require that in at the top. So const responses equals require / common / API responses. So this means that when we get a new connection, we're going to log it out and return a 200. What we're now going to do is copy this into the default disconnect and message lambdas and adjust the functionality slightly for each of those. So here we're going to send a message of default disconnected, and finally in here a message of got a message. This is because this is the backbone of what we're going to be doing. Back in our connect.js, we're going to add some extra functionality. So what we actually want to do is when a user creates a WebSocket connection to our API, we want to store them in a database. We want to store some information about them regarding their connection and a list of messages that they have sent to us. To do this, we first need to get some sort of unique identifier. Luckily, when a WebSocket is connected, they give us a connection ID. So we can destructure that off the event request. So const connection ID. I'm just going to rename this to connection ID capital because that is the format I like to have things in, equals event dot request context. So now we have a connection ID. We want to store some data into Dynamo. We already have a Dynamo write, so const data equals an object, an ID of connection ID. We want to set the date to be date.now. And finally, we want to have an array of messages, which for now is going to be empty. Now what we need to do is we need to write that to Dynamo. So here we can await a dynamo.write. And in here we need to pass in the data and a table name. The data we already have, but the table name as well as Dynamo needs to be brought into this file. The first thing will be Dynamo, so const Dynamo equals require going down into the common folder and then Dynamo, which we can see here has a get and a write. So the only thing we now need is a table name. As we've done before, we're going to be getting this from environment variables. So const table name equals process.env.table name. This will be a parameter that we pass through inside the environment variables from Serverless. The next thing we need to do is a disconnect. So in a disconnect, we want to do something similar to what we've done with the connection, but we actually want to delete the ID from the Dynamo table. So the first thing we need to do is get the connection ID. So const connection ID of, and we're going to rename that again to connection ID equals event dot request context. Now that we have that, we can await dynamo dot delete, passing in a connection ID and a table name. We have the connection ID, but we need the table name, and we also need Dynamo. So I'm going to go back into our connect.js and copy those over into our disconnect folder. So some of you may have picked up on this, but Dynamo doesn't currently have a delete function on it. So we're going to go into dynamo.js and scroll down to the bottom and add our own delete function. So this delete function needs to do one thing, which is make a delete request on AWS Dynamo DB tables. It will be an asynchronous request that needs an ID and a table name. What we need to do is create some parameters that will be passed into our document client delete. So const params equals an object. This object has a table name as well as a key, which is an object with an ID in it. After this, we then need to make the request. So we're going to do document.client delete. This takes the parameters, and we can add .promise on the end to make sure that it returns a promise, and we can return this. If we save that, we now have a delete functionality that will work with Dynamo DB. Inside our disconnect, this now means that if there is a delete passed up because there's been a disconnection of the WebSocket, it will delete it from the table and return a 200 of disconnected. The last thing we need to do is go into our messages and create some extra data in here. Again, we're going to be getting the connection ID, but we're also going to be parsing the body. So const connection ID, which we're going to rename to connection ID equals event.request context, and we're going to define the body equals json.parse of event.body. So This is where we're going to be receiving a message on the body that we want to store in that array that we created on the connection. To do this, we need to update a record. The way we're going to do it here is we're going to update it by getting the record, changing it, and then rewriting over the existing record. So inside this, we're actually going to use a try catch so that we can wrap multiple requests in one error handling method. So try, and here we're going to be getting the first record. So const record equals await Dynamo dot get, and we're going to be passing in the connection ID and a table name. As we did before, we need to include the table name and Dynamo inside this file, so I'm going to paste those in at the top. So now that we have the record, what we need to do is we need to manipulate this so that the messages have an extra message which has been received added onto it. So const messages equals record dot messages, and then we're going to push a new message onto that. So messages dot push, and we're going to be pushing on body dot message. This now means that the message array will have whatever we pass up inside the message field on the body of the request down the WebSocket. The next thing we're going to do is we need to write this back into Dynamo DB. So const data equals an object. Now most of the record is going to be the same. So what we're going to do is we're going to spread the record, which means every single one of the fields on the record object will be put as if they are fields in the data object. But what we can do now is we can overwrite them by writing a new field with the same name over the top. So we're going to pass in our new messages, which has been pushed with the message we got down the WebSocket. This may seem a little bit complicated, but for now this is the way that we're going to have to do it. Now that we've done that, we can just simply write this back to Dynamo. So await Dynamo.write, writing up the data and table name, and we're going to return the response of 200 got a message. Because this is a try catch, we actually need to implement our catch. So if there is an error, we need to handle it within here. We're going to handle it by returning a 400 response, and this is going to have a message of message could not be received, and that is now our message.js file completed. This is actually all of the code completed, so now what we need to do is set it up inside Serverless. So inside Serverless we need to do a couple of things. The first one is we're going to be defining an environment variable, which is then going to be used in all of our files, and that has a name of table name. As we've done in previous lessons, we're going to be using a custom value here. So self : custom.table name, which means we need to define that down here. So custom has a table name, and I'm going to call this WebSocket users. As well as that, we are writing to a Dynamo DB table, so we need to give permissions to our Lambdas to read and write from Dynamo. This is done with an IAM role statements. Here we're going to have a statement of an effect of allow. It's going to have an action, which is an array, and on this one we're going to be doing a Dynamo DB : star, which means we can read and write to Dynamo. And finally the resources. Sorry guys, there's a bit of a typo just here. It's meant to be resource, not resources. We all make typos occasionally. So this will allow us to read, write and update those records, as well as delete them. So those have all been configured, and that is the setup for every single Lambda. So now we actually need to create those Lambdas, as well as specify that they are triggered via WebSocket. The first one I'm going to create is a WebSocket connection. So WebSocket -connect. This has a handler, which is Lambdas / WebSocket / connect.handler, and with the events which trigger it. This is a little bit different to what we've done previously with HTTP requests. This has an event of WebSocket, and this has a parameter of root. So routes are the way that API Gateway decides which of the Lambdas should be run depending on what has happened to the WebSocket. In this case, it's a connection, so it is a value of $connect. So this will say create a new Lambda that whenever a WebSocket connects, it triggers this Lambda. We're going to copy all of this, as the setup is very similar for the rest of the functions. The next one is WebSocket disconnect. So changing the Lambda to be called WebSocket disconnect. The handler is Lambda's WebSockets disconnect.handler, and the root is $disconnect. The third one is WebSocket default. I'm using VS Code, and it has a really useful hint where you can press Control or Command and then D to select the next word that is the same, which means you can edit them all at the same time. This allows me to change all of these, so it's WebSocket default, Lambda's WebSockets default.handler, and the root is $default. The last one we need to do is WebSocket message. So we have WebSocket message, which is the message.handler. This time though, we don't need the $. This is because connect, disconnect and default are all inbuilt roots, whereas message is not an inbuilt root. With this, we actually have to pass up a root identifier so that it knows which of the Lambdas to send it to. So if we save this, we have now defined all of our functions. Because we are saving to Dynamo, we do also need to create our Dynamo DB table. So to do that, as we've done in previous lessons, we're going to create a new resource. So resources, and inside here we're going to have a WebSocket user table. going to have a type of AWS Dynamo DB table. It's going to have some properties, which are a table name. So we've already defined the table name up in our custom values, so we're going to be using that. So back in our resource definition, the table name is $ curly braces self : custom dot table name. We also have an attribute definitions, so the only attribute we're going to define is an ID, so attribute name of ID and attribute type of string, so just S. And we also need to define the key schema for this, so key schema attribute name of ID and a key type of hash. The last thing I need to do is define the billing type, so billing mode, and we're going to be going with pay per request because setting up auto scaling with this is a lot more complicated. So this pay per request means that we only pay when we actually use it, but it automatically does scale up without charging us when we're not using it. So once we've saved all of that and scroll back up to the top, we can now get ready to redeploy this. At the moment we're in the WebSockets folder, so we need to cd into the root folder with .. to get back into the My Serverless project folder. And now we can run SLS deploy, which will deploy our application. This takes a little while to do, so I'll get back to you when that is done.
2 hours later.
Now that this has finished deploying, we can see that we have the 4 functions as well as an endpoint, which this time starts with WSS, defining that it is actually a WebSocket. So what we can do is we can copy this URL. Unfortunately, we can't test this using something like Postman, but there is a useful website out there to do it. So I'm going to head over into my browser and go to websocket.org/echo.html, which is a site where you can test out WebSockets. We're going to do this by changing the URL and pasting in ours and hitting connect. Here it is logged out that we have connected. So to test this, we need to go into our AWS account and see what has happened. Inside our AWS account, we can search for Dynamo DB. Inside here, if we go to tables and WebSocket users, inside the items, we can see that there was a user connected. They have a date and 0 messages. This is great as we have added this user when the user connected to our WebSocket. If we now go back into this test facility and hit disconnect, it says it's disconnected. So go back into Dynamo DB, refresh it, and you can see that it has been deleted. This means that both our connect and our disconnect lambdas are working perfectly. The last one we need to test is the message one. So if we connect one more time go back into Dynamo and see that we now have a new user. Inside our WebSocket, we need to change this message. So we need to change this message to be an object. And this object needs to have two properties. The first property is the message that we want to send, which I'm going to set up a message of, hey, this is a WebSocket message, as well as one other parameter. If we go into our AWS account and search for API gateway, we can see that we have our dev my serverless project 2-WebSocket, which is a WebSocket connection, and this is the endpoint that we created. Inside here, you can see the routes that we created, and there is a route selection expression. This means that if we want to hit this message endpoint, we need to specify it in the body.action. So if we go back to our echo test, we have our message, but we also need to have an action which specifies the route that we want to go down, in this case, message. Finish the object off and hit send, and we are sending that message. If we now go into Dynamo DB and refresh the page, we can see that this account now has a message of, hey, this is a WebSocket message. This means it has been added to our account and added into this Dynamo DB message array. If we go back into our echo test and change the message slightly, so this is a WebSocket message 2, and hit send, back in Dynamo DB, refresh it, open it up, and we now have two separate messages. Now that we've created a platform that can receive a WebSocket connection and save messages into a Dynamo table, we want to be able to reply with messages back down that WebSocket. To do this, we need to make some changes to our code. In our code, there are a couple of things we need to do. To send messages back down the WebSocket, we need to store a domain name and a stage so that we can send them to the correct WebSocket, and then we need to set up a way of sending those messages. The first part is relatively simple. If we go into the connect.js, on this request context, there are actually a couple more parameters that we need. So we're going to extract those here, and they are domain name and stage. With these values, we're going to add them to the connection data that we store in Dynamo DB. So domain name and stage. So that is all that we need to do inside this file, as we won't be sending any messages from here. Where we will be sending messages is from the message function. In here, what we're going to do is we're going to reply to any messages that we get. To do this, we need to add some code after we've written the records back to Dynamo. And in here, we're going to await a WebSocket sending. So await WebSocket.send, and we're going to pass in the domain name, the stage, the connection ID, as well as a message. This message, as it's going to be the first message, is this is a reply to your message, And the other thing that we need to do is get the domain name and the stage off the record. The way that we're going to do that is by refactoring this bit just here a little bit. Instead of it just getting the message off the record, we're going to get the record and we're going to destructure message as well as domain name and stage. These should be on the record as they were stored when the WebSocket connected. So the one thing that we now need to do is create this WebSocket send functionality. So in our common library, we're going to add a new file and we're going to call it WebSocket message.js, and we're going to jump into that file. In this file, we're going to be using AWS's SDK, so we need to import that. So const AWS equals require AWS-SDK. So there are two parts to sending a message back down a WebSocket. We need to set up and configure the WebSocket API gateway management, and then we actually need to post the message to the connection. The first thing we're going to do is create that connection. So const create equals a function that takes a domain name and a stage. And inside this function, we first need to create an endpoint. So const endpoint equals, and this is a amalgamation of the domain name and the stage. So I'm going to use string templates, and it is domain name / stage. So this is going to generate a URL for us, and then we need to return a new AWS dot a lowercase pi gateway management API, and we need to create this with some parameters. The first parameter is the API version, which for us is going to be 2018-11-29, as well as the endpoint. So this is going to set up the API gateway API management, which will allow us to send messages down the WebSocket with this domain name and this stage. Now that we have that set up, we actually want to be able to add some functionality to send the message down that WebSocket. So const send is going to be a function again, and this is going to accept a couple of parameters: the domain name, the stage, a connection ID, as well as a message. To create the WebSocket, we're going to actually call the create function, so const ws, short for WebSocket, equals create, and pass in the domain name and the stage, just like that. Now that we have the WebSocket created, we need to create the parameters that we're going to be using to pass into AWS. So const post params equals an object. The object has data, which is just going to be our message, and it has a connection ID, make sure it's capital I lowercase d, equals the connection ID. Now what we're going to do is we're going to post that to AWS. So we're going to return ws.post2connection, passing in the post parameters, and we're going to use .promise to turn that into a promise and an asynchronous request. Now that we have this send functionality, we need to export it out of this file. So that is module.exports. And instead of just exporting this one file, we're going to export an object which contains the send function. This means we could extend this in the future so that we could do something like send an array of messages and create a new function that does that. So we're going to save this file and head back into our message endpoint code, as we need to import that into this file. So const WebSocket equals require .. to get down to the common folder, and inside common it is the WebSocket message file. So now WebSocket message has a function of send on it, which allows us to pass in the domain name, stage, connection ID, and this message so that we can send it all. Now this is done, we can save this file and run SLS. Deploy one more time, and this will deploy all of these new changes so that we're sending a message down the WebSocket. Now that this has finished deploying, we can head back over to our browser, to the WebSocket connection, and we can try a new connection. So if we hit connect, this will connect a WebSocket, and now we can try sending a message again. And as we see, we have sent this message, but then received the reply from our WebSocket. We can add this send message code anywhere we want in our code, and to be honest, anywhere that you have access to that Dynamo DB database, you have access to the domain name and the stage, and therefore you can send a message from wherever you like. This could be triggered by an event that happens in your software where you need to send a notification, such as a message in Facebook Messenger, or you could send a message down a WebSocket if an event has happened in a game or something similar to that. In this video, we have learned how we can set up a platform that allows us to accept WebSocket connections. We've used API Gateway, Lambda, and Dynamo DB, where we've stored all of the session data inside those Dynamo tables. We've seen how we can connect a WebSocket to our platform, send messages, and then receive messages back down the WebSocket. This can be used in a huge number of applications, from messaging services to notification platforms and many, many more things. If you've learned something in this video, it would be a massive favour if you hit that like button, because it really helps the YouTube algorithm show this video to more users and more developers like yourselves. And if you want to know about more videos coming up, make sure to hit that subscribe button and turn on the bell notification so you get notified the next time I upload a video. Thank you, and I'll see you again next time.